So what about artificial intelligence? Well, what we really wanted to do was look at the reality behind the headlines, the promises, and listen to people from very different areas who are all working in artificial intelligence right now. So we want to put your questions to our panel of speakers to explore how the NHS is using AI. What could be possible? What are the barriers? Is it really that complex? And how can patients be involved? In essence, what is the reality around AI? So I'm really pleased to say we've got three great people to come and talk to us this morning from different parts of the UK and very different backgrounds. We'll each describe their own personal perspectives of how artificial intelligence is used in healthcare and their roles within that. Our three speakers are John Rigg from IQVIA. It's a commercial data organisation which has been working with health data across the world for many years and are very active in artificial intelligence. Anna Grace Linton is a researcher from the University of Leeds, who can describe her work using artificial intelligence to understand unstructured data provided by patients. And Sandra, Irvine, a Use My Data member from Northern Ireland, was being involved in AI projects as a patient. We've asked all our panelists to avoid acronyms where possible. I've realised I've already used the term AI. I think that's probably excusable for this one. But to speak in plain English and to focus on a patient audience. So if there are things that you don't understand, again, please tell us that by using the Q&A function. Put anything you want in there. And after all the speakers have spoken, we'll open these things up for questions. Okay, so let me start then by asking our first speaker, John Rigg, who you just heard from IQVIA to begin. I have to say, when we were planning this webinar, I spoke with John and his colleagues as we wanted to find a commercial organisation, a big organisation that was using data and artificial intelligence to help bring a bigger picture view of the topic. And I have to say, after listening to John for 20 minutes, I thought it was perfect. He was a man for the job. So I'm really pleased that John's able to come with and give his time to us this morning. John, so I think you've got your colleague Alba with you ready to run your slides. So I'll let you introduce yourself properly and the floor is yours.
Thank you everybody for the opportunity to present. My name's John Rigg. I work at IQVIA, which is a pretty large organization globally, about 85,000 people. We run lots and lots of clinical trials. I'm not in that part of the business. I run an AI practice, and we develop various AI solutions, and I'm going to elaborate on that in a little bit. But I've been with IQVIA now for about nearly 10 years. So, Albie, if you can press the next slide to go to the agenda. So I'm going to talk a little bit about what we mean by sort of machine learning and AI. I'm going to talk a little bit then about sort of the growth in healthcare in terms of the spending and some of the applications we're seeing. Then some sort of projects that we've got on the go at IQVIA that hopefully this audience will find interesting. And then I'm going to comment a little bit on maybe some of the barriers I think that we're facing here in terms of large-scale implementation of AI solutions in healthcare. And one of the themes that I want to try to draw attention to, especially in that last section, is that I think AI has lots of promise. It's exciting. It can really add an incremental value to supporting patient outcomes and disease management. But there's very, very few examples really at the minute in terms of large-scale implementation. I want to reflect on that and think about some of the challenges we need to overcome to achieve that. So next slide, Alba. So this is just an example of some of the sort of different algorithms that we've developed down the years. And it's quite an old slide, so we probably now done maybe 400 or 500, maybe more. But nonetheless, I think it gives a reasonable picture of the different disease areas. And I think a couple of things I'd like to draw attention to. Maybe a disproportionate number of the work that we've done is in rare diseases. And this is maybe for good reasons, because a lot of the pre-diagnostic journey, for instance, for rare disease is not really very well known. And so there's a lot of focus on using machine learning here. Also, predicting disease progression is really important. So you can try to get interventions to those people most at risk. Non-adherence is another big area. Most of these algorithms have been developed in partnership with life science, for example, for R&D purposes. But my focus these days, very much in the last 2, 3, 4 years, has been trying to integrate and bring solutions closer to patients and closer to providers. So next slide, please, Alba. So what do we mean by machine learning? I've got a definition here, an explanation which hopefully helps. So what I've written here is machine learning can be thought of as a collection of analytical methods designed to produce predictions. And it's particularly adept at searching through large volumes of complex data to identify associations between inputs and outputs. And there's a couple of things I'd really like to draw attention to in that sort of definition, which is important, I think, to try and understand. The first is the analytical objective. So we mentioned here prediction. So, when we think of analysis, there are lots and lots of types of analysis that we want to do analysis for. So we want to do inference, for example. So, what's the association between, let's say, age and the onset of COVID? If you want to do inference, you don't really need machine learning. We've got standard tools that we've been using now for 40, 50 years, which are fine. Sometimes we want to do description. So there's lots of other analytical objectives. So it's only particularly helpful where prediction is a paramount analytical objective. The other thing is we have. I mentioned here about using large-scale complex data. And this is really important. If we generally just have a few variables to hand, I mean, this is a sweeping statement, but usually these machine learning methods are generally a little bit of a hammer to crack a nut. We don't necessarily need it. So where we have very complex and large data, such as lots of images, for example, data is a classic example, but there are many other examples. Then we can find that we can get real, this is the sweet spot for machine learning. So it's very much a subset of instances where we have very complex large-scale data and where the paramount analytical objective is to make predictions. And then one other point I just would like to draw to your attention is we have, it's generally speaking in sort of traditional analysis, what we would do is we would think of exactly it's what we call a deductive approach to sort of deductive scientific philosophy. So we think, for example, in the case I just said a minute ago, of what is the relationship between age on the one hand and, say, COVID on the other hand. And then we design a piece of research, and then we'd study that and find the relationship. So this is it's a hypothesis-driven approach, and much of statistical analysis is very much like that. Machine learning is very different. We very much are open-minded about which are the important risk factors or determinants, and we allow the data to inform that decision-making process. So it's very much a data-led, or as we say, an inductive approach to scientific philosophy. And it's not like one is necessarily better than the other approach. It's just that both are wonderful and appropriate in different settings and contexts. Both approaches have pitfalls, so we need to make sure we understand what the perils are and to make sure that we have the guardrails in place. So in summary, machine learning is all about making good predictions when we have large complex data, and it's a data-driven approach. And if you can think of AI, again, there are 1,000 different definitions, but if you think of AI as the application of machine learning, then in many instances you won't go too far wrong. Great. Okay, so the next slide, Alba. What we've got here this is the US trends, but it's globally applicable. So it's the trends I want to draw attention to. AI is growing. I mean, no one's going to be surprised about that. It's growing in healthcare. It's growing all over the place. So we've got some numbers here that quantify this. We have it's growing from around, in terms of AI, healthcare AI in the US, gone from about 1 billion in 2021 to around 10 billion in 2017 to 2021. In terms of its share of digital health spend, it's gone from around just over 18% to almost 30% in the space of a few years from 2017 to 2022. So there's two things that I'd like to draw your attention to about this. I mean, firstly, this is a steep trajectory. This is rapidly growing technology and capability. But the other thing that I think is equally as important to draw attention to is it's coming from a very, very low base. I don't know what the total spend here is in terms of the US healthcare, but even 10 billion is relatively small. So the point being that with every emerging technology and capability, we'll make errors, we'll make mistakes, it'll be used in areas which are not entirely appropriate. So, as we go on our journey and think about how to benefit from this new sets of technologies and so on within healthcare, I just think we need to be open-minded about the potential, but also about, not too quick to embrace it and remember and reflect on the fact that it is in many ways embryonic. The other point on this slide I'd like to draw your attention to is it's a survey, a piece of analysis that was done a couple of years ago by Accenture. And what they pointed out is some of the really emerging applications within the healthcare space. And some of these, maybe not be surprised about, such as clinical diagnostic algorithms using images, for instance, and robot-assisted surgery. But I mean, certainly in our experience, I would say that the majority of applications are really on the operational side. So error, fraud, waste, and abuse is a big bucket, and it covers lots of things. And I think that it's understandable why that's the case. And a lot of it's to do with regulation and the fact that it's a lot easier to build something that's going to automate your appointment scheduling or whatever it is than it is to have a diagnostic algorithm and go through all the regulatory processes. So let's not lose sight on the fact that AI is making contributions, but a lot of it's behind the scenes in terms of the operations. Okay, next slide, Albert. When we started our journey, or my journey at least, which is in this space in healthcare, which is close to 10 years ago now, I said, oh, we can use machine learning to try to find undiagnosed patients with rare diseases. And there was a lot of skepticism. And so we developed a quite a robust study, which is being published, and the results, summary results are here. And even though this is quite an old study, I'm going to call out some of the findings because time and time again, these findings have been replicated by us, and we've got dozens of publications, but also by other organizations, by Google and by others. And I think it's worth keeping some of these, reflections in mind or observations. So this is about a rare disease. It's called tuberous sclerosis complex, TSC. It's 1 in 15,000 is the prevalence. It's actually oncology. It's a cancer. But the cancers themselves are not malignant, they're benign, but they manifest themselves in different organs, in kidney, in the brain, and so on. And it leads to various adverse manifestations, which themselves are life-threatening. And like many, many rare diseases, there's a big problem here in terms of late diagnosis. So important to try to identify these patients early. What we did on this project, and it was a retrospective project, so we didn't deploy this live. We just used some data and said, how well does these algorithms do? We linked primary care data with secondary care data. And we developed 4 algorithms. So one algorithm, the first was, we had access to a wonderful panel of clinical experts, and we were very privileged. And we said, well, if you were looking, we said to these clinical experts, for us to deploy this algorithm in your clinic, how accurate would it have to be? And what they said is that they wanted it to be somewhere between 1 in 5 and 1 in 10 patients. So for every 5 to 10 patients that they screened, they would want to find one sort of true patient. I mean, this is quite, remember, this is a rare disease. When we're doing algorithms for diabetes and for other things, those numbers are a lot smaller, but this is a rare disease. So the first algorithm, we talked to these clinical experts, and we said, what should we look for? And we looked at the epidemiology literature and everything else, and we built a set of rules. And then we built an algorithm based on their knowledge, and we queried the data. And we showed that this sort of, let's call it for every 25 patients that this set of rules flagged, we got one patient that was subsequently confirmed as having the disease in the data. So that's a 1 in 25 rate. So they were happy it was better than 1 in 15, but somewhat disgruntled it wasn't down to what they needed. We then applied a very, very standard traditional statistical epidemiological approach, and we got the number down to 1 in 13, so it's a big improvement. We then applied a very, very crude machine learning model. We just basically threw the data at the algorithm and saw what it did. And we were pretty surprised and impressed. About 1 in 6, it got right. That was the screening rate. And then what we then did was said, well, how can we make the best of both worlds? Because we have this wonderful information here from these clinical experts. And then, we have something that's very encouraging in the machine learning, but it's pretty crude. And so we combined the domain knowledge in various ways. And there's a huge literature out there on how to best combine expertise from multiple domains to produce a harmonized sort of hybrid model, which I haven't got time to go into now. But the principle is that, and we've done this countless times again, really try to think about the wonderful clinical knowledge that's available and think about how best to incorporate that into a solution. Next slide, please, Alba. So this is a project that we've got ongoing at the minute that I thought I might share with you. I think it's a really great project. This is around hepatitis C. So again, a problem here is that this is a disease that's very underdiagnosed. Around 40 to 85% of people are estimated who've got the disease, estimated not to be diagnosed. And, it's life-threatening, serious problems with liver and liver cancer and transplants and so on. In recent years, there's been some innovations with, near curative treatments. So a lot of countries have got hep C elimination programs. So what we've done is we've developed a prototype algorithm, and we're talking to some of these health systems in different countries about how we can, support some of their hep C elimination targets. So the prototype algorithm we actually developed it using some US data, covering non-hospital settings. We had around 70 million patients in that data set that we used. So it was a really big data set to build an algorithm on. And just a couple of the results from that. The algorithm, so there's lots of benchmarks here, and to compare against. One of the baby boomers, the birth cohort is one well-known high-risk group, and the algorithm did about 4 times better than that. And did about 3.3 times better than another well-known high-risk group, about patients who have injectable drug history. So overall, we felt that was a positive result and worth continuing and talking to health systems. If anyone's interested, by the way, we published this fairly recently, a few months ago, in the BMJ and Healthcare Informatics journal. So we're now talking to, we're in the middle of a project to deploy this in Australia, for instance, and we're talking to in France and a couple of health systems in the US about trying to localize this algorithm. It needs to be made fit for purpose for the local environment and to deploy it. Okay, next slide. And here's some work that we're doing in the UK around heart failure. And, everyone knows that heart failure it's very serious. It's also a very underdiagnosed, estimated around 300,000 people in the UK with undiagnosed heart failure. One of the really sort of tragic but also fascinating sort of epidemiological observations is that there's around 41% of patients that present in primary care with at least one symptom. And if you couple that with the observation that around 80% of people who are diagnosed with heart failure are actually diagnosed in secondary care in hospitals, it just demonstrates that there is huge potential here to work with primary care in the UK to see if you can bring forward the point of diagnosis a lot earlier and get people on the right treatments, the right sort of interventions, because 40% of newly diagnosed people with heart failure die within a year. So it's important. And actually, so we've been working with primary care practice now for quite a while, number of years. They are very incentivized to work in this area. It's clinically very important, but also there are various financial incentives for primary care networks to hit certain milestones in this area. So there's a couple of things that we've been doing. One is what we call a heart failure plus. So there's a lot of patients who, have been GPs recognize that they've got heart failure, but maybe for various reasons they've not been properly coded in the system, and they've critically not been put on the heart failure register. And it's important to get patients on the heart failure registry, because a lot of the disease management initiatives and reviews and everything else is driven from that heart failure register. So what we did is developed an algorithm, a set of rules, try and help clean up the sort of the EMR record. We piloted this in 12 practices. I think that's published somewhere. I can double check if helpful. And now we're rolling this out. I mean, I think last year something like 1,000 practices used this tool to help improve the integrity of their heart failure registry. And what we're looking to do at the minute is really scale that and automate that. It's still a little clunky and a little manual around the edges, which is suboptimal. So we've developed a thing called the IQVIA Healthcare Analytics Network. We have GPs sign up to this network, and we help them with rolling out various analytics solutions, including this one. So we're hoping to get coverage around a third of the UK population in 2-3 years. And this would be one of the things that we're helping primary care with. The second thing is, so one thing is around making sure that people are on the register so they get the appropriate disease management. The other thing is, there's a lot of people clearly who have not yet had heart failure, not yet been diagnosed, but are clearly of high risk. So the other thing we've done is developed a machine learning model to predict these sorts of patients. We developed that algorithm on a data set covering 2 million patients, and we're currently just about to launch a pilot covering close on 500,000 patients. So when that's complete in a few months' time, we'll seek to publish that so that can be widely available. Just checking on the time here. Okay, I'll speed up a little bit. So the next slide just shows a couple of dashboards, really. So generally, when we develop solutions, there's sort of two components to how an analytics solution might be used. One is the point of care. So what we're trying to do here is help, physicians, doctors at the point of care, give them information that can support some of their own decision making. So these typically solutions are integrated into EMR system or into care management platforms. The second one is population health. So this is, care coordinators, these types of HCPs, healthcare professionals, have responsibility for broader disease management questions at a population level. And these are just a couple of dashboards, really, that show the types of information that is helpful at each of these for these views of the world. And very quickly, one of the problems that we always face in AI is about explainable AI. It's really important to make sure what is being viewed by a clinician or by any healthcare professional is able to be understood and interpreted, so that they are able to both independently verify and then take action on. So the next slide, and the final slide for me, I want to circle back to the theme that I mentioned at the outset here. I'm of the fervent view that machine learning, AI, it can really, it has a lot of potential. And I illustrated, for example, in that TSE case study, how I think it can really help improve the accuracy of our ability to identify some of these undiagnosed patients, for example. There's lots of other use cases, but it is not being used very widely at the minute, and we've got to think about why that's the case, and what we can do to make these solutions implemented at a large scale. And I've just written down some of the challenges that I think need to be thought through very carefully, and there are many more than this. And one is around the software as a medical device. The frameworks are still evolving. UK governments, MHRA and various bodies are contributing to a consultation right now. This uncertainty doesn't help, but it's of course necessary. And even where there are guidance, such as, I mean, the US FDA just came out with their guidance a couple of months ago. You know, it's great, it's very helpful, and in many ways it's very comprehensive, but there's lots of not so edge cases that are overlooked by that guidance. And there's nothing there about dynamic and self-learning algorithms and things like this. So we've still got a lot to do to bring clarity to help the community developing these solutions. Another concern is around privacy. I mean, I'm sure most people are aware of a lot of the regs around this area, probably more so than I am in many ways. But it is a balance. We have to get the balance right between the protection of data and between the ability to use that data in ways that can inform healthcare. And I mean, maybe I'm on the wrong side of the fence here, who knows? But I come across lots of examples where I think they're very straightforward applications of data, but yet to get permission for that, you know, often takes a long time. So I mean, I've got lots of ideas on how we can streamline that process and not sacrifice any of the high standards we need all to adhere to. I mean, one example was in the UK, we wanted to link a data set. It was uncontroversial in many ways. A huge bureaucracy and things we had to go through, and 3 years later we just gave up and moved on. So, you know, we need to provide a climate to stimulate innovation, but that needs to adhere to very high standards of data privacy, and I don't think we're quite there just yet. Another quick comment on compliance. We work, perhaps unsurprisingly, a lot with life science companies. And there is actually a huge overlap between the interest of life science and the interest of patients and the interest of providers. I mean, we've talked about, you know, early diagnosis and things like this, which are often of mutual interest. But where there is mutual interest in a lot of countries, the frameworks that for life science companies to be arm's length, but yet to sponsor initiatives is very complex and it's not developed. It's pretty good in the UK for various reasons, but in most countries it's not there, and that's a barrier. And we need to think about what are the guidelines that need to be adhered to foster public-private partnerships. And then the final comment I'm going to leave on here is infrastructure. You know, every health system, it's got you know, it's got its own, often its own data standards. You know, there's often it's in unstructured fields, some key information. You know, common data models are not that common. Often data sets are not integrated. They're not, you know, latency is a problem. The infrastructure, you know, we've got cloud environments, we've got, you know, Oracle, we've got lots of different types of environments. So the concept of having algorithms which you can take off the shelf and just deploy is very, 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 very hard to do. You know, there's a lot of customization. And I think until we resolve some of these problems around integration and so on, and the interoperability movement in the US is doing some great stuff, I think we're not going to quite get there because the economies of scale don't quite stack up. So that's some of my personal reflections. You know, as we go on, you know, welcome questions and reflections of others. And thank you, Chris, and everybody for the opportunity to present.
John, thank you. It's a fantastic start, particularly ending bit where you're basically describing all the problems we have with data at the minute. It's just going to be made worse when you're trying to work with AI and machine learning, but we can go into that a little while. Thank you for all the questions that are coming in at the moment. Please keep those coming in. We'll pick those up after the three speakers have spoken. So Anna, I'm going to let you have the floor now. I'll let you introduce yourself as well. And are you running your own slides? Yeah. Perfect.
Great. Thanks. Thank you, everyone. As Chris said, I'm Grace Linton. I'm a PhD student at the University of Leeds. I'm also part of the Centre for Doctoral Training in AI for Medical Diagnosis and Care. And that is essentially a group of research group of students here at the University of Leeds that are looking at different ways they can apply AI technologies to different medical problems. So my PhD is looking at AI and how it can be used to analyze the free text comments that we see in patient-reported outcome data. So, as you may know, the survival at 10 years has increased from 24% to 50% over the last 40 years. And this is due to a lot of the innovation and research that's happened in cancer, in and around cancer research. What this has meant is that there's now a shift in the focus, not just in increasing the survival of patients, but also looking at the quality of life that they have following diagnosis and especially following treatment. I found this cartoon series by an artist called Alex Branchley, and I found it very informative and insightful at looking at some of the aspects or the nuances and personal experiences that patients may have after they've gone through diagnosis and after they've gone through treatment, especially. So you can see examples of, the fatigue that patients might experience, or the peripheral neuropathy that would, is quite common following chemotherapy. And this kind of variation or more detailed aspect of their quality of life that my research is really focusing on, really looking at more than just what your clinical papers say that you are, how healthy you are. What does the patients think about their own health status? What do they think about their own quality of life? And this is where patient-reported outcome measures come in handy. I try to avoid abbreviations, but I will be calling it PROMs from here on in. And PROMs are essentially a questionnaire survey that is sent out to people who've undergone a intervention. So in my research, I'm looking at the intervention of cancer treatment. And it allows for a self-assessment of their health-related quality of life. And this is often used by clinicians or researchers to understand the factors and the influences on the patient's quality of life at that moment in time. It is shown to be quite important and informative in understanding, providing additional treatment as well as understanding the clinical relevance of the interventions that have been made. Specifically, I'm focusing on the free text comments of these surveys. So these surveys contain both open and closed-ended questions. And it's these open-ended questions where patients can add anything that they would like to add in addition to the information captured that is most important to me. This is because we find that in these open-ended questions, patients mention things that are most relevant to them, most important to them to mention. Bearing in mind that these questions are often at the end and often optional, so it is the person taking the additional effort and additional desire to present information. Often contained here, you see information regarding, elaborating on a score, say earlier on in the survey, or writing about information that they felt wasn't captured by the closed questions. So you can see that these free text comments are rich and abundant in information and insight into the patient's quality of life, but often the data we find, the information we have here is far too much to be analyzed. If we take an example of the National Colorectal Cancer PROMS data set, this was collected several years ago, but we see that there were about 20,000 responses from patients who had been diagnosed with colorectal cancer in the year and the year before that it was collected. But this resulted in about 5,600 responses in free text comments. So imagine analyzing this manually. Analyzing this manually, this can take a lot of time. It's also very resource heavy and time consuming. So often this means that the closed questions get analyzed using statistical measures quite early on in the analysis process. But then the free text comments often get left and delayed and analyzed at a later date when more resources are available, more convenient, or sometimes not analyzed at all. We see examples of this with other patient-reported outcome measure surveys, as well as other patient experience surveys. So this is where AI can come in and be quite useful. So what it does is uses this large amount of unstructured data and automatically processes it into something that is structured, something that's insightful, that researchers can then use and apply and put into practice. So my research focuses on this area, trying to get us from A, the unstructured data, to B, the insights into the health-related quality of life. This is a bit of an overview in terms of what it is that my project's trying to do. So we have the PROMS comments. So I'm looking at the colorectal cancer data set that I mentioned, and seeing how we can apply a particular form of AI that involves text analytics, or natural language processing, or NLP, many of these words that you may see coming out. These are the techniques I'll be using to see, A, can we pick up the topics that are being mentioned in these free text comments? Can we understand the sentiment to which these topics are being discussed by the patients? And then what does this tell us about their health status currently, or at the time of the survey? I'm also looking at then, if I include additional patient data, be it such as the demographic information, or the survival and mortality rate at a time point after the survey was taken, or even actually responses that they provided to other parts of the survey in the closed questions. What can this tell us about the patient's health status at that time? And also maybe what does it tell us about the patient's developing health status? What can we predict using the information from these free text comments? And when looking at how AI can be applied here, you can see it being used mainly in this region through the automatic detection of the topics, the automatic detection of the sentiment, and also then the automatic analysis of all the information that you're providing it. But I guess for me, there are several things I need to consider in my research. First of all, the data type that I have. Unlike a lot of the text data that many of these models that you may come across are working on, the comments in the free text comments are very short, maybe a few sentences, at most a paragraph. So actually we find that many of the models or the methods that are used in similar data sets or similar user-provided data isn't actually applicable for the PROMS data. Additionally, we have that mixture of patient-specific terminology or cancer-specific terminology mixed with the layman term language to describe an aspect. For instance, even in the cartoon that we showed earlier, the talk of peripheral neuropathy, the fatigue, these are very concrete and medical terms, but actually many times when patients describe these symptoms or these effects in themselves, they don't use those specific terms. May use other variations or synonyms or colloquialisms that we also have to understand and find the most appropriate AI methods to look at this. And Chris mentioned in his presentation, actually, it's when you do have, you have applied these AI methods to look at your data, and you're producing an analysis and understanding of what you've now actually looked at. How can you actually make this useful or understandable to the end user, being the researcher who's actually going to use the information that you've now acquired to put into practice, and use this information to act on to actually improve and understand the patient's health status in a more holistic manner. Additionally, what is it that the patients whose data this actually comes from, who this is, what do they find useful about the analysis that we are able to make? I'll give you one example being that in this particular data set, there were 20,000 overall responses. Only a quarter of these provided free text responses. So what is actually valuable to actually understand, and this is mentioned, I think we're talking with another patient group actually, and I know Richard Stevens is in the audience as well, it's actually what is the bias that we see? Is there a bias in those who leave the free text comments? And what's, what can we pick up about this? What does this tell us? Also, is there a bias in who says what? And I think a lot of what the additional patient data allows us to do is actually look at, is there a difference in what an older patient may talk about as the most important factors to them compared to a younger patient? Maybe is there a difference between say social deprivation of the patient and what they are finding most crucial to talk about? And so that's generally an overview of what my research is looking at. And I hope that has been quite insightful and helpful, and I hope it brought up a lot of questions regarding how AI can be used in a different way, and even a data set they hadn't quite considered it could be used for. Thank you, and yes, looking forward to your questions.
Anna, thank you. And there are lots of questions coming in, as people can see. And just a reminder, put your own questions in and also vote up other questions which you see are interesting as well. Thank you, Anna. That was a really nice example of what a practical use of AI within, in this case, University of Leeds. So Sandra, we're now moving to you from another different perspective, which is from a patient perspective. How does all this feel as somebody who's been involved in a piece of AI work?
Okay, good morning, everyone. Emily, could I have the first slide up, please? Okay, good morning, everyone. I'd like to thank Chris and Use My Data for inviting me to speak to you this morning. Unlike the first two speakers, I am not an expert in AI. I am a patient advocate based in Belfast, and I've been involved in PPI through the NCRI and through the Northern Ireland Cancer Consumer Forum for about 8 or 9 years now. So I just want to present to you this morning a little bit of my experience of trying to integrate some PPI in an AI project and getting what I think has turned out to be a reasonably happy mix for all concerned. Could I have the next slide, please, Emily? Okay, so this is the formal title of our project. It's essentially an image-based AI project involving the pathology department. So they're looking at imaging slides and looking for specific markers related to personalized medicine. So it's a joint project between the Personalised Medicine Centre at Queen's University, Belfast, and a spin-out company from the university called Sunrise Analytics, who are providing the AI-based element of the project. The project has been funded by NIHR for 3 years, and we're currently almost exactly halfway through the project funding. Next slide, please. So the group of researchers were very good about thinking about including PPI right from the very start. So I was involved in writing and submitting the grant, which went through a stage 1 and a stage 2 element. PPI is very much part of everything that happens. The group have monthly project meetings of all the different work packages, and PPI is one of those with equal standing in terms of reporting and input. We also decided as part of the submission that we would get together a small subcommittee of PPI representatives. So we have 5 people within the group. The project is looking at markers related to colorectal cancer and lung cancer. So the members have all got experience of one or other of those. And we've been funded for 2 meetings per year. Now, when we applied for the grant originally, this was in the middle of COVID. So we applied for 1 meeting, which would be carried out via Zoom, and the other meeting, hopefully face-to-face. And we did manage with the timescale to get round to getting some face-to-face meetings in. The things that we were tasked with doing was, apart from contributing on an ongoing basis via these monthly project meetings, to develop a piece of educational content alongside the researchers involved, and to organise a public event at the end of the project. Next slide, please, Emily. Okay, so I said we're halfway through. So where have we got to so far? So the academics, I suppose, were fairly predictable. Their idea was they wanted to carry out a survey of public and patients to find out what attitudes were towards this sort of approach to work. So the PPI group were involved in reviewing the content of the survey and making input into how it was structured and how it should be carried out. So the survey was carried out just before Christmas time. The data are currently in and they're with the academics for analysis. Now, as you can imagine, this will take some time. So our input to that at the moment is on hold. But once they actually get some particular threads coming out from that, we will again have some input to it. And the output of that is ultimately, as academics generally want, to get some form of publication in a journal. The company researchers, and by that I mean those within Sonrai who are doing the AI work, and also those in the laboratory who are doing the pathology work, engage with us in a slightly different way. So the first meeting that we had was via Zoom. And what happened was we had a half-day meeting, more or less, where we had some of the researchers present to us about what AI is, what AI is involved in the project that they're carrying out, and how they thought we might get involved with them. So that was very good. They're all very good at presenting their work, and it was a very stimulating thing, but very much them to us. Then our face-to-face meeting was a visit of our group to the laboratories where the work is carried out so that we could see exactly what they did. And again, we found that very useful and very helpful. So far, these sorts of approaches are very, I suppose, standard and fairly predictable. So if I could have the next slide, please, Emily. Okay, so then we turned it round and said, well, you have been giving us a lot of information. We would like to have more of an input to you. We wanted to raise our voice. And because the project had started during COVID, many of the staff who were involved with the work were working remotely and hadn't even met each other. So they decided that they would have a couple of meetings where they brought everyone on board. So the meetings that we normally had input to were those that were led by the work package leads. So they had tasks in hand that they knew had milestones to be met, and they discussed specifically those. So this was a bigger forum. So there were about 40 people there, all the workplace package leads, plus all the researchers, many of whom were just used to sitting behind a computer screen. And two of us went to the department for this face-to-face meeting and presented the lived experience. And it was very interesting to see the response of the researchers to that. The meeting ended up running a lot later than anticipated because there was a lot of engagement and a lot of questions from the researchers, and them saying things like, oh, so that would mean if we do this, that would have an impact in this way. And I felt that it was very useful for them. And in fact, the feedback from them was that it had been quite stimulating for them. The second thing that we did, which has made probably the most impact, is that within our group, we decided that rather than waiting for the outcome of this survey that the academics were doing, that we were just going to take a very simplistic view of the top 5 questions that people asked us and that we were asking the researchers in various formats. We submitted them to the research group, the research team, and they then nominated a key person to answer each of the questions. And 2 of us from the PPI group went to the department, and we had a company video us asking the questions and then having a response from the researchers. And this has turned out to actually have been a really strong feature of the PPI work. The researchers were highly engaged. They all enjoyed doing it. We felt that we were getting more to the nitty-gritty of what we actually wanted to know. The company and the university have both been challenged by it, because we said to them they were all very excited when they were awarded research funding and put something on their websites to say, oh, look, we've got this great grant. But there was nowhere on their site to give updates to anyone who was interested in the work going on of exactly what was happening. And also from the company point of view, they have realized that they have to explain what they're doing, not just to other people who are in AI, but to professionals who are going to be using this tool, and to people like oncology nurses who may be speaking to patients who know that AI has been used as part of their diagnostic process. So although we went on board to ask 5 questions, these have now been edited, and we are now in negotiation with both the company and the website about tidying up their websites to have somewhere where they could have information in a more lay-friendly language for those who may be impacted by this technology. That we're going to organise some stage 2 interviews, which will be discussions with other healthcare professionals. Clinical oncologists and oncology nurses, for example, have been suggested. We've also, because of this, I think, been getting a lot more direct communication from the researchers, not just in terms of meeting their goals and their targets for the next stage of what's going on, but finding that within the licensing of the product, because at the end of all of this, they want this to go out into the commercial realm, they have to answer certain sorts of questions. And they're now coming to us and saying, well, look, is this clear? How could we explain that? How could we go about something? And I think that it has taught both of us something, in that although you think perhaps you know nothing, and I still would not say that I know much about AI, you can contribute by asking pertinent questions and looking for answers. And that perhaps it is more value to the researchers than even they understood at the beginning. And I feel we've much more of a two-way relationship now, whereas at the beginning it was a little bit one-sided. So thank you all very much.
Sandra, thank you for that. That's another really good insight into what it feels like from your perspective to be involved in some of these things. And certainly some of the key messages around getting the patient voice to embedded within the work, making sure that you understand what the work is, communicating that and using our voices to communicate those things as well is particularly important. So those of you who are watching the questions, you know there's a bundle of questions come in, which has been impossible to get through everything. So I've just been trying to pick up the most popular ones and theme some of them. So I want to start with one, which is the top question in your list, voted up by most people, which is around health inequalities. And the question is, what is being done to reduce the health inequalities that might arise from not having health data from more underrepresented patient groups in the data? I don't know whether is that something, John, you might want to comment on from the sort of the higher level view around of this, because you already work with some significantly large data sets within IQVIA. What are the problems that might arise from not having health data from more underrepresented patient groups in the data, and are we going to increase inequalities in some ways?
So this is a great question. It's a great question. And thinking, for example, about the Hep C project that I mentioned earlier on, I mean, you know, a large number of people with undiagnosed Hep C are in the homeless community, and we just have very little data on those in the standard GP records, for instance. So it's a brilliant question, and there's a really nice example. I mean, my personal observation is I think we are in the stage of our knowledge discovery where we're just trying to think about what are the implications, what are the problems, how can we quantify them, and how can we build best practice standards. So I think that's the stage we're at now. And there are some nice guidelines that have been published by different organizations, governmental bodies and things, trying to think through some of these issues, you know, ethical AI and things like this. What I would say is that the bias and fairness literature is pretty important. What we try and do, for example, on a lot of our projects is quantify some potential biases or known biases that we have, but we're very cognizant that there's a lot of unknown biases. The other thing I draw people's attention to is often it's not just about algorithm development, it's about the way these things are implemented. So, for example, on the Hep C project I mentioned, going back to that, we're working with various practices in Australia, and they're specifically targeting fairly sort of low income areas where we know that Hep C is pretty high. So overall, I'd say that there's a growing awareness of some of these challenges, and I think we're a long way from systematic solutions, but it is an active topic of academic research as well as practitioner interest.
Yeah, thanks, John. And I see you were nodding along with some of those things, Anna. Whether you want to make a point or just you're agreeing with John.
No, I mean, I was mainly just agreeing with John in that aspect, and I think really explained it quite well in terms of a lot of the focus now. I think we realize the impact of having imbalanced data sets and not representative of the population. I'm sure, and many of the articles regarding some of the health inequalities and how that was reinforced with some of the algorithms that were put out or during the COVID-19. And I think as John mentioned, like the first steps at the moment is actually quantifying the impact it has, where there are sort of stats, so there's evidence, and there's evidence you have to kind of look into it. So there's been a lot of work in terms of quantifying the impact of having such data sets. There's some research or exploration into how we can kind of account for this in terms of what can we say, augment the data. So if you only had 10 of a particular category of that's being unrepresented, how can we sort of, see how we can maybe replicate this data or make it seem as if take a more proportion of the data set? How does this then affect how well we can mitigate against bias in the data when we're then training it? And there are many other kinds of ways to try and see how can we look at this maybe technically, how can we work with the data we have, the unbiased one. And I think there's still a lot of work to be done there. And I think with the idea that is at the forefront of sort of research at the moment, I think is really the sort of spearhead movement into actually looking at how can we practically address this, both getting people involved, but also what the data we have, what can we do?
And talking about people being involved, Sandra, you've been involved in some AI projects. Did the conversation come up with you as part of that team about bias within the data? So the risk of not including certain groups. Another question similar that's been raised is around ethnic differences within patient groups and whether those things were being considered within your project. Have you come across that?
I have come across it, yes, and I think it's very much recognised as a challenge. But I mean, we are trying to address it, but I wouldn't say addressing it as well as we would like to. I think it is an ongoing challenge for everyone, no matter what sort of work they're doing at the moment, to make sure it's fully inclusive. The only thing I would say is I think the AI does allow us the opportunity to become more inclusive than we are currently, because we have the opportunity to access data that is not necessarily where we are at the time. We can access things extraneously, and that at least gives us some opportunities to redress the balance.
Okay. And another similar question or related question that came on, which I bundled in the equality pile of questions I've got, was around language. So if people speak in different languages and record their notes in different languages, are there similar AI algorithms working on different countries using different languages that we know about? That might be a question for you, John, because IQVIA work across many countries, don't they?
Yeah, so I mean, just for context and perspective, the vast majority of sort of machine learning solutions use structured data, so they don't use case notes and things. Even within case notes, then there's lots of established NLP solutions based on common languages like English and Mandarin and Spanish. But some of the other languages less so, and it's a problem. It's definitely a problem where using sophisticated NLP tools on languages which are maybe less common. For sure. It's not my domain of expertise, but I'm very much aware of that challenge.
Yeah, and NLP is natural language processing, which is for people who don't realize that. And so it's interesting. So John, you were basically saying that from what I've read in what you've said, that the optimal use of AI as we stand is heavily focused on structured data. That's data which is codified and structured and well organized, rather than unstructured data like free text, which is what Anna's working on. Would that be fair?
Yeah, that would be my assessment. I mean, there's still lots of wonderful work that's been done using the, various free texts, including the problems information that Anna mentioned, but also case notes. There's lots of others trying to extract diagnostic information from PDF files and, text information on lab values in PDFs. These are being used, but the low-hanging fruit is what's the structured data, for example, that's in EMR. So these tend to be the solutions which are most common, leverage that, relatively speaking, the low-hanging fruit.
Yeah, okay, understand that. I just want to move on to a slightly different topic now, because we've got lots of questions to get through. It's actually focused on primary care. The question is, could AI, machine learning, revolutionize primary care decision support systems to speed up correct diagnoses? But there's a few other things which link to that. And one question I thought about was, you mentioned, John, that you're using primary care data, other organizations doing similar, and yet we have some significant issues particularly in England, around poor and decreasing access to primary care data. So if AI and machine learning could revolutionize primary care, is this a way that we could show some really good examples to build the trust in people about how primary care data could be used for benefits, rather than just people thinking about risk all the time?
Yeah, so good question. So, I mean, what I'd say is, firstly, that the word revolutionize is a strong word. I probably would disagree that AI could revolutionize primary care decision making. But what I would say is, I think that there is very rich data that's available. I think that it's extremely underused. I think that even some simple analytics on top of that can go a long way for closing care gaps. And look at I mentioned the Heart Failure Plus project that we've got. I mean, the algorithm's not that complex, really. It's a set of rules. And that's just one example of, you can hugely increase sometimes between 10 and 50%, the volume, the number of people on the heart failure register. And then on the back of that, you can, have a lot of disease management type improvement initiatives. I mean, that's just a little example. I could give many more in asthma and COPD and things like this. So in general, what I would say is that I think we can use the data that's available, coupled, often with some very insightful analytics, to really move the needle. I'm not sure I call it a revolution, but it's definitely hugely increase the clinical benefit and the operational benefit. And I think a subset of that is where there are particular instances where it really does make sense to machine learning. So if you wanted, for example, to find early diagnosis of lung cancer, well, there's no point just looking for people who have got, smokers with, backache and things like this in the data, because it's not sufficiently specific. So you'll need to come up with some more complex models on top of that to try to really, make it usable in clinical practice and not overly burdensome. So I'm very optimistic on generally the use of data and analytics. I think it can make a huge difference, and I think there is a role within that for AI. I'm not sure if that amounts to a revolution.
Yeah, interesting. Yeah, lots of the hype that we hear in the media and elsewhere is around AI is going to revolutionize the world, but we'll see. Okay, I just want to go to a slightly different tack now, which is around involvement in the work that each of you have done now. Sandra, you described nicely the work that you have done as a patient on the work around Northern Ireland. Maybe a question to the other two then, and you can comment, Sandra. Anna, for your project, have you got patients involved in your work, or is it not at that stage yet?
So yeah, with my project, the intention is to have patients involved with the work. So we've had, so in the collection of data, which was work sort of done before my research, the patient involvement there in terms of informing the research that was going to be done and the way the data is going to be collected. So there's patient involvement there. At the moment in my research, I haven't had explicit patient involvement in terms of presenting with results and being able to get feedback and feeding that back in. That is sort of in the process for me. There's a moment of going through the ethics to allow for such focus groups, but it's something that's planned into my research project. I think I've had the benefit of being able to present the work I'm doing in forms like this, and previously as well with patients to be involved. I think there's definitely, well, I've noticed that there's a very, and with my project and with other projects like mine, working with AI and health within the CET, there is definitely a desire to work with patients, and it's built into the design of the project. I would admit that the challenge is sometimes getting it quite early enough into the project. It takes a while to develop the project for a while, understand what actually is that you want to share, but maybe I think this question is quite challenging, is actually maybe even as a PhD student, we do include in the formulation of the research project rather than just the presentation of this is what I have, is this what you want element.
So Sandra, you've been doing this on a few projects for a while now. What advice would you give to Anna about the best stage at which to involve people like you, and indeed where would you find people like you to be involved?
Well, I think that the truth of the matter is that you should involve patients at all stages, right from the very start when you're planning. I think your project looks great, and I think most patients would be extremely supportive and very, very interested. Around most, certainly university, hospital type establishments, anywhere where there's research going on, you'll usually find that there are patient groups that you can tap into who will be happy to support you with people who maybe have an interest in that area or who would be willing to get engaged with you. At the beginning, it's useful in terms of formulating the questions you want to ask. And in the middle, it's useful in terms of the sort of answers you're getting. Is it going the way you expected? Are there other things you should be taking into account, other ways of thinking at it that you probably hadn't thought of before? And laterally, how you're actually going to present it. How are the general public ever going to know what you did? People in the academic world tend to present to each other. So they go to conferences and they talk to other people who are doing something very similar, but often that doesn't filter down to the people that are going to be affected on the ground. And sometimes you've got the greatest supporters there who will actually help you take your work on to the next stage. So I think it's important at every stage that you're doing it. But then, of course, I am biased.
Well, we don't bias, yeah.
Yeah, but the interesting thing is, one thing I have found has challenged the researchers recently is a lot of the grant awarding bodies now insist on having PPI involvement. And there are people coming to us with projects who are going, like, I have no idea how patients could really get involved with this, but essentially to tick the box to submit the grant, I've got to come and ask some people. And that has forced them into doing it. And I think most of them have been surprised in a positive way that they have actually gained from it too. So I would encourage you to seek out people at whatever stage you're at.
Couldn't agree more, Sandra. In fact, just in practical terms, if any of you, your colleagues, Anna, or indeed any other research teams who are on the call at the minute, need to get access to people who want to get involved in complicated research like AI, then just get in touch with Use My Data, because we've got lots of members, we've got lots of friends in loads of other groups as well who will jump at the chance of these things across the UK. So it's very well put. I just want to follow on a bit about involvement. John, yours is a very different perspective because you're working in a very large commercial organisation. Are you able to involve patients and others in the sort of work you're doing in your prioritization, what you're finding, and communicating what you've done to others, or is that more difficult for you?
I'm not sure it's any more or less difficult than any of the other colleagues and panelists here. I mean, I think the prioritization for us is often driven by a business need, for instance. But at the end of the day, when we come to implementation, we have to get the voice of the patient. So I think that's a universal across any, across all, irrespective of the owner or the developer, and whether it's public, private, or academic. I think that's probably true. So, I'm not sure our challenges are unique in that respect.
Okay. And I suppose the same offer is, if you've got colleagues in IQVIA who need access to patients who are interested in this, please just give us a shout. We've got 10 minutes left on our webinar, and there's loads of questions coming in. I want to focus on one question which I suspect might go to Anna and to John particularly, which is around, once an organisation, or indeed in Northern Ireland, Sandra, once your spin out company in Northern Ireland has developed an algorithm, a machine learning or an AI algorithm, what's the process by which, once it's implemented, somebody can say, actually, I want to move to a different algorithm? Is it easy to switch from a user of an AI algorithm to a different user? Are we there yet? Maybe I'll start with John on that one, maybe, because you've got a commercial hat on.
I need to try and understand this a bit better. So switching from a user to,
well, if an organization is using one of your AI algorithms, how easy is it for them to switch to somebody else's AI algorithm if they think it's better?
Right. Yeah, no, that's okay. Well, it's not easy. And I come back to the sort of the final point that I made when I was doing the presentation. We've got, there's so much heterogeneity in the data and the technology, that, it's hard enough to get anything up and running at scale. I mean, switching one algorithm out and putting another in place is, I just think it's very hard. I mean, we're still at the point of our collective journey where we're trying to get proof points and demonstrate value for any algorithm, never mind thinking about how we supersede one algorithm with another. So I think we're not at that. That's probably not a pressing question that I'm coming across at the minute, just because we're fairly early on in that journey. But it's not easy. There are standards that are being developed, and there's some wonderful organizations publishing standards that are not just trying to make that, the goal of these standards is to try to have some degree of uniformity so that we can understand, the methods that go into this, the data, how it's used, everything else, so that portability of solutions and ease of implementation, these are some of the goals. And of course, from a technology point of view, with things like, Docker and containers and things like this, we are beginning to move into a world where, we can lift and shift a little bit easier. So I think there's trends in that direction. And it is a good question. And I'm not sure where it's not like replacing one lamp with another lamp just yet.
Mm.
Can I just say, I put my hand up. I'm not an AI expert, but I know from the discussions I've heard with the pathologists that a lot of them, in terms of the project I've been working on, there's another company working in this space who also originally was a spin out from our university, and they're working on prostate and breast cancer, where the project I'm working on is on lung and colorectal cancer. And the whole discussions that I have heard have related to the sort of kit that's present in the NHS laboratories that could be turned around to use each of these sorts of algorithms without them having to go out and buy a whole new system each time. So that's the only bit that I have heard discussed. So whatever is there, if you're in the NHS, you've got a budget. If you suddenly want to introduce a new algorithm, you don't want to have to go out and buy a whole new system to work with it. So most of the things that they have been discussing developing seem to work along using one conventional line of kit or with a very small amount of variability. Otherwise, they would never be able to get it integrated into the NHS. It would be too expensive.
Clearly a whole new world we're moving into here, I think. We've got about 5 minutes left. I'm going to put one quick question, which is very, very specific, which was related to something on this morning's Today programme, BBC Radio 4, about a blood test connected with bowel cancer, which had been tested by the Royal Marsden. Is this an area which AI could become involved? You may choose to defer that question unless anybody wants to answer that specifically. I'm not sure I have an answer without knowing what the thing is, really.
Yeah, so I mean, just quickly. So, I mean, I don't know the specifics here at all, other than what you've just said. What I would generally say, though, is if generally it's a simple blood marker that, we know what we're looking for, I don't think there's any need for AI. However, where it's really helpful are, if, for example, it's there's no one specifically blood marker, thing with marker within the samples, but it's a collection of different things which together may be indicative of risk, then more complex methods such as machine learning may help. May help there. That's for sure. That's the type of instance where it would be helpful. So it depends on the complexity of the data and the simplicity of existing markers to indicate the at-risk population.
Thanks, John.
I'm aware of it as a marker in a number of colorectal trials, and they only mentioned this specific trial this morning. It is being used elsewhere, but it is sort of, I don't see it as something that would be AI applicable in this sense. It's a blood test, but as John intimates, in some of the trials it may be part of a wider range of markers that's being looked at, and that may be where the AI element could come into it.
Yeah, sorry, I'm not aware of this particular case study, but I think there's probably, I'm not sure if asking in terms of is there potential in terms of the automation of the process of trying to make it more effective or efficient, I should say, or is it sort of maybe, I think Sandra kind of pointed out, can we use the information that you have from these blood tests and these blood markers actually maybe combining it with actually other information as well, to get more maybe out of it. I think maybe in that sense, that's Sandra saying there, so we can get maybe AI could be, the potential of AI could be actually explored.
Thanks, Anna. In our last 3 minutes, somebody has brought Elon Musk into it. Of course, we brought Elon Musk into the conversation. The question goes: people such as Elon Musk are asking for a halt to be brought to AI development. Any comments? Maybe we could take this as a bit of a roundup. Heck, good luck with this one, folks.
I'm happy to give it a first shot. So, I mean, what I would say is that I think there are genuine areas actually where we do have legitimate concern. Especially, I mean, we think about clinical, we keep talking about decision support, but where it's ultimately the algorithm that's really driving the decision, I mean, that's definitely an area I think we need to think very, very carefully about. The solution for me in that instance wouldn't be, oh, let's stop developing. It would be make sure that the algorithm is doing what it's intended to do, which is supporting an independent clinical decision. That's what I'd say there. But what I would say, the other sort of comment is, this world of machine learning is big. And I think the vast majority of things that are being used, it's being used for just a fairly uncontroversial, in my opinion, and we wouldn't want to stop then. So, for example, I get in the car every day. We use the GPS to get from A to B. It's very helpful now. It tells me when we've got traffic jams and all the rest of it. I wouldn't want that to be any less accurate. I don't want to lose my way even more often than I do already. I think I want that to be more accurate. And I think that's just, I mean, I think 99.99% of you probably would agree that's just an example of something where it's wholly beneficial. And I think that the vast majority, I mean, I'm blind. I've got a white stick. There's now technology to have radars in that to help locate where walls are and all the rest of it. I mean, I don't think it's a bad application. I don't think there's any danger there. I want to keep on innovation, to keep on driving benefit. So I think the vast majority of things are fairly uncontroversial. Let's not throw out the baby with the bathwater, I'd say.
I agree completely, John. I think we have to be very careful what adjectives we use when we're talking about AI. I think if we think we're too revolutionary, it scares people and it puts them off all the good things that are perhaps a little bit more mundane, but actually very, very useful. So I think not pause, but consider everything that's going on, give thought to it, and certainly be very cautious that you don't throw the baby out with the bathwater, because there's a lot of good and we don't want to lose that.
And I think at that point, we've got with 1 minute, if we have to draw a close to that, I think it's a really good way to end, because it's clear there's a lot of work and thinking to be done about AI. There are some clear concerns people have raised about, is it going to introduce bias? Can bias be introduced into algorithms? That's a lot of work that we've done on that. Huge focus on, let's not disadvantage the underrepresented groups, those who don't see themselves in the data, to make sure that AI doesn't exclude them. John's point about AI is not just about it's going to make the decision for you. There has to be a thing about decisions versus decision support. The point about expectations, AI, its reality is still working on a fairly low level at the minute, but the opportunities are huge. Let's not stop the non-controversial stuff. I think that the thing that sums all this up for me, what I'll finish with, is it seems again to be around communications. If this is all going to work, we've got to take people, patients, the public with us. And the only way we're going to do that is to communicate clearly what it is AI is about, what the constraints are, recognize where its weakness and the concerns are, but equally recognize where we can do some really good things with it. And around that, the governance, the control, and total transparency about how this is operating. So if people want to find out, they can find out, they can get involved. Sandra can get involved in her project, with many others getting involved in projects, and a much tighter communication with the public about AI and healthcare. And on that note, I think we need to draw this to a close. I'd like to thank the speakers for all their time and energy they put into this. It's been really good working with them. It's been good fun. Emily, particularly for organising this, because this has been the last one she organises for us. Thank you, Emily. And everybody in the audience and the delegates for turning up and putting such good questions in. I realise we haven't answered them all. Some of the speakers may want to pick some of them afterwards, but we'll put all the questions up on the website with the recording as well. So thank you very much, everybody. Have a great rest of the day and a wonderful weekend. Okay, thank you all.